Okay, hi everyone. This is Infinity Tutorial channel. Please remember to like, subscribe, and share. So this is a continuation of the video that we did last time, and we are to solve an example on large samples of a confidence interval. Now the question is the height in inches of 100 students of a particular college is presented in the table below. It said A, determine the unbiased estimate of the true mean. B, determine the unbiased estimate of the true variance. C, construct the 95% confidence interval for estimating the true mean. And of course, this is the table. They gave height and they gave the numbers of students, but the heights that they gave were in range. So the first thing you have to do if you are given this kind of question is what you consider the numbers of students that you are going to calculate for. So since it's 100, and we know that for our large samples that n must be greater than or equal to 30, okay, and of course 100 is greater than 30, which means we are using our large sample. So the next thing you have to do is to solve for the unbiased estimate of the true mean, the variance, and of course you solve for your confidence interval. So we have to convert this table to the table we are going to use for this question. They gave us height, they gave us numbers of students. Now I need to construct my frequency and I need to find the value of my x. From this table, the numbers of students is our frequency, okay? So we draw another line. We call it the frequency. Okay, and from here the first frequency is 5 given by next 18, 42, 27, and 8. Okay, so you write it down. 5, 18, 42, 27, and 8. Okay, you rule. Now the next thing you are going to do from here is the height, okay? But we are going to use this height to find our x. Since the height is in ranges, what you are going to do is add these two values and divide it by 2, okay? Add the two values and divide it by 2. Now for the first one, that is 60 to 62. So you're just going to add 60 plus 62 divided by 2. So that will be your value of x, okay? So the value of our x so for the first one, which is on 5, the value of our x is 61. Okay, now for the next one is 63 to 65. So just add 63 plus 65 divided by 2. That's 64. So the next one is 64. The next is 66 to 68. 66 to 68. So 66 plus 68 divided by 2, which is 67. Okay, next next one you have is 69 to 71, and if you do that you're going to have 70. Then the next one is 72 to 73. If you do that you're going to have 72 to 74 rather. If you do that you're going to have 73. So this is how to get your value of x, or the x values. So, and remember that the summation of all this frequency is equals to 100. So just come down here and sum your frequency, which gives us 100. Okay, so let's go back to the question. Now, the first question says that we should determine the unbiased estimate of our true mean. So the unbiased estimate of the true mean is your bar x from the formula that we gave in the earlier video, the bar x, okay? And the bar x for a grouped data, and this kind of data is called a grouped data. This kind of data is called a grouped data, the one that has been grouped. So the value of our x, which is our bar x, for a grouped data is equals to the summation of f of x divided by the summation of f. Okay, so you are going to get the summation of your f of x and you divide it by the summation of your f. This f stands for frequency, and this x, of course, is the value that we've gotten from here, the values that we've gotten. So next is you have to create a different table for your f of x. You have to create a different table for this. Now our f of x is simply the multiplication of your frequency and the multiplication of your x. Okay, just multiply your frequency and multiply your x values and you get your f of x. So that's 5 times 61, which gives me 305. 18 times 64, which gives me 1152. 42 times 67, which gives me 2814. 27 times 70, which gives me 1890. And the last is 8 times 73, which gives me 584. So what I'm going to do next is just to add the values of my f of x. Okay, that is what the summation means. It means that I should add the entire values of f of x. So if I should add that, I have 305 plus 1152 plus 2814 plus 1890 plus 584. So what I'm going to have is 6,745. Okay, so you come here, we have 6,745. And remember that our summation of f is just the summation of our frequency, so which is 100. So if you should divide, you are going to have 67.45. Okay, that's what you're going to have if you divide it. So this is how to calculate for your unbiased estimate of the true mean. Now we are done with the first one, our A. We are done. So the next one is to solve for the unbiased estimate of the true variance. Okay, so to solve the unbiased estimate of the true variance, how to do that is for unbiased estimate of a true variance is given by the formula variance is sigma squared, and the variance for an unbiased estimate is given by the summation of fx squared minus n x by x squared divided by n minus 1. So this is how to solve for your the unbiased estimate of your true variance. Okay, so you're going to create a different table. You're going to create a different table for your fx squared. Okay, and this n means the total number of your frequency. Okay, that's what this n means. And this by x, of course, we've gotten our by x already, so you're just going to square the value and you're going to divide by n minus 1. The total value of the n here is 100, so you're going to divide by that. Remember that the reason why we are subtracting 1 from the n is because we are dealing with an unbiased estimate. Okay, so the next thing you're going to do is to create a table for your fx squared. You are going to create a different table for your fx squared. So what it means is that you are going to square the values of your x and you multiply it by your frequency. Okay, square the value of each of these x and multiply by the frequency. So by doing that, we have the first one, the first x is 61. So you're going to have 61 squared multiplied by 5, which gives us 18605. The next is 64 squared. 64 squared multiplied by 18, which gives us 73728. The next one is 67 squared multiplied by 42, so which gives us 188538. The next is 70 squared multiplied by 27, so which gives us 132300. Then the last is 73 multiplied by 8. Okay, so 73 squared multiplied by 8, which gives us 42632. So that's how to get the values of your fx squared. So the formula from here is that we are going to sum the values of this fx squared. So we are going to sum the values. Okay, so sum all these values. So we have 18605 plus 73728 plus 188538 plus 132300 plus 42632. What we have is what you have here is 455803. Okay, that's what we have. And the is actually subtracting the n multiplied by x squared. Okay, so what you're going to do here is to use 100, which is our n. 100 multiply by the by x, and our by x was 67.45, so times 67.45, and you square the value. So if you should do that, you divide by n minus 100, which is 100 minus 1, which is 99. So just input in your calculator the value and your answer pops up. So we have so the answer is 8.6136. So you can probably approximate to, let's say, a reasonable figure, 8.6136. Okay, let's leave it here, 8.6136. So that's the value of your variance. You've solved for the variance. Now the next thing you're going to do is to solve for a confidence interval. Now remember, from our confidence interval, we need the value of our standard error of x, and for you to do that, we need to find our standard deviation. Okay, we need to solve for our standard deviation, and our standard deviation is given by just square your variance, the values of your variance that you got, just square it. Okay, so standard deviation is equals to the square root of the variance, which is equal to the square root of 8.6136. So the square root of 8.6136 is equals to 2.9348. Okay, so let's just approximate to 2.93. So this is how to solve for your standard deviation. So the next step is to start solving for your confidence interval. Okay, and to solve for the confidence interval, we know that our confidence interval is given by the formula by x plus or minus z alpha over 2, the standard error of x. Okay, so that's our formula for z alpha over 2. So the next step you have to do is to determine your z alpha over 2. And this z alpha over 2 is gotten from our statistics table. So just go to your stats table, and before you do that, the alpha, they say we should construct a 95% interval, which means that our alpha is equals to 5%. Okay, I explained it earlier. So, and 5% is same thing as 0.05. So since when you want to determine this z alpha over 2, I told you are going to use the formula z1 minus alpha over 2, which is same thing as z1 minus 0.05 over 2. When you do that, 1 minus 0.05 over 2 is same thing as z of 0.975. Okay, it's the same thing as z of 0.975. And when you go to your statistics table, the z of 0.975 is given by 1.96. So the z of 0.975 is given by 1.96 from your statistics table. Now, the next thing we are going to do to evaluate our final answer is to get our standard error of x. And remember that the standard error of x is given by sigma divided by the square root of n. Okay, that's the value, and our sigma is 2.93. So we have 2.93 divided by the square root of 100, which is the value of our n. So divide by the square root of 100, which gives us 2.93 divided by 10. And when you do that, you're going to have 2.93 divided by 10. You're going to have 0.293. So you're going to have 0.293. That will be your standard error of x. So the only thing you have to do is just impute your values into this formula and everything pops up. Now, by imputation, we know that bar x is something as 67.45. So you come here, 67.45 plus or minus our z multiplied by the standard error of x, and our z was 1.96 multiplied by the standard error of x, which is 0.293. So 0.293. So when you do that, just get 67.45 plus or minus. So we have 1.96 times 0.293. So we have 0.57428. So now to determine your confidence interval, you are going to have your upper and your lower confidence interval, the upper and the lower. Now to determine your upper is to add, and to determine your lower is to subtract. So for our upper will be 67.45 plus this value. That will be our upper, plus this value. So we have 68.02. Okay, that will be the upper value. Now our lower value will be this value minus this value. So 67.45 minus the lower value, which is 0.57428. We have 66.875. So I can approximate to 66.88. Okay, so that is the value of our confidence interval. So we are confident that 68.2 of these people are actually in this college, and we are having a lower confidence that 66.88 of these people are in this college. So from this question, so I believe that this video was useful and helpful. Please remember to like, subscribe, and share. Thank you.